Mobile Cloud Computing. Abstract Mobile Cloud Computing, MCC, heralds a novel era in computation within which consumers of cloud technology are attracted to numerous web amenities. MCC has a super-quality, adaptable, as well as economical delivery platform for offering internet-based services to mobile cloud customers. Numerous investigations on solving a number of challenges in MCC have indeed been carried out due to the delivery stage's benefits. Energy efficacy in MCC, quality of service-aware MCC, QoS, safety, plus customer-contented app are some of the apprehensions. In this regard, this study provides a qualitative assessment of several MCC approaches that have been offered. As a result, a taxonomy for MCC is provided, with significant research areas such as QoS-aware, energy-aware, cybersecurity, and application advances considered. Each of these issues is comprehensively evaluated, with contrasting judgments taking into account contemporary developments. The results of a study of measurements and deployment settings used to assess the effectiveness of existing strategies are provided. Ultimately, based on a comprehensive plus qualitative examination of publications, several open research questions and new challenges for scholars in this subject are indicated. Keywords: Mobile Cloud Computing, Mobile Devices. 1. Introduction. Since smartphones have become a necessity for humankind, mobile MCC has seen a fast expansion concerning exploration. 1. It is movable and available at all times, making it incredibly efficient and suited for communications regardless of time or location. MCC's inception represents a considerable shift in computer science technologies as well as smartphone companies. Electronic mobile banking, EMB, electronic mobile game, EMG, electronic mobile learning, EML, electronic mobile commerce, EMC, and electronic mobile healthcare, EMH, are some of the services that use MCC. Meanwhile, due to the growth of vast and complicated programs, mobile devices, MDS, are getting increasingly complex. As a result, MDS face battery capacity, storage capacity, and processing power constraints. As a result, the concept of exporting tasks to the cloud has been implemented into portable devices too. As shown in Figure 1, which depicts the MCC system perspective, shifting work to the cloud resolves many difficulties, including cybersecurity, QoS, and mobile app development. Sophisticated algorithms are required by real-time technology, computer graphics, speech processing, online games, streaming video, linguistics, and wearable technologies. In developing the programs for portable gadgets, these complicated applications present a challenge for mobile devices, MDS, app creators. Because of the growing demands for new smaller MDS, the challenge of battery power dissipation and storage capacity is becoming increasingly significant in MCC. As a result, adopting solutions of cloud technology for portable gadgets has become critical. Several sorts of studies have recently been aimed towards MCC to handle issues that have been mentioned earlier. When operations are transferred to the cloud, problems of privacy, accessibility, and authenticity must be considered too. The exporting architectural style must include identification, confidentiality, and end-to-end protection. Since data may be transported then warehoused in the cloud through a wireless link, it is critical to provide efficient and robust task conveyance from MDS to the cloud. Transmission becomes susceptible to cyber threats, both internal and external, due to the wireless link. QoS is critical for ensuring that the work is transmitted efficiently into the cloud technology. Due to the remote connectivity, which may lead to a lag in communication, QoS is taken into account. Before outsourcing a job to the cloud, consider network stability and phone traffic. I2. Literature review. Cloud technology systems like Windows Azure, Amazon Web Services, as well as Google App Engine have grown in popularity among IT firms and programmers in latest years. Concurrently, the use and implementation of smartphone apps plus platforms has skyrocketed over the globe. The present condition of the craftsmanship in the integration of these two prominent concepts, which are referred to as MCC, is discussed in a IJERT 10 is 110020 www.ijert.org. 42. Study focused on the assessment of cloud expertise and imminent developments. 3. The study shows how MCC may be used in a variety of fields, including m-learning, e-commerce, healthy lifestyle, and social networks. Smartphones can now accommodate a diverse set of apps, many of which require ever-increasing processing power. Since smartphones are resource-limited devices with minimal computing capability, storage, memory, plus battery, this creates a problem. Thankfully, cloud computing model provides nearly limitless reactive compute, storage, as well as service provisioning capabilities. To address the limitations of smartphones, experts foresee expanding cloud computing services to mobile devices. The difficulty is that typical smartphone application frameworks do not facilitate the creation of cloud computing-enabled apps, necessitating the use of specific mobile cloud application paradigms. For this article discusses mobile cloud computing environment, offloading decisions that affect organizations, application paradigm taxonomy, the most recent mobile cloud-based architectures, rigorous assessment, and future study prospects. Diverse MCC research projects have been presented to address difficulties of growing power consumption, poor and inconsistent connectivity, plus scarcity of resources of mobile gadgets, according to 5. Moreover, a categorization based on the mentioned concerns is provided, with important concerns considered. Additionally, prospective study prospects are identified, as well as an examination of concerns that have not been thoroughly investigated. It is planned to conduct a security-focused investigation that examines the various solutions used to resolve MCC security gaps. Security amenities are presented on many tiers, along with a program, framework, architecture, supervisory tier, and core overlay, according to the study. Prospective MCC concerns are also explored, as well as the categorization of security vulnerabilities. Nonetheless, the research only looked at the MCC security component. 2-3. MCC protocols, taxonomy. In its most basic form, MCC alludes to an architecture that stores and processes data outside of the portable device. Cloud computing apps transport data warehousing and processing power from mobile phones to the cloud, offering programs and MC to a far more extensive range of mobile customers than simply smartphone users. In this subsection, a classification represented in Figure 2 is used to assess the quality of MCC. Cloud technology is a growing study area in portable gadgets, thanks to more complicated and resource-intensive mobile apps. The concepts of cloud-based solutions are being merged into mobile computing to reduce the problems that mobile gadgets face, such as battery life, storage capacity, and processing power. The study focuses on 4 main challenges: energy-aware obstacles that lead to work offloading to the cloud, cybersecurity, applications, and QoS-aware in MCC 6. Each of these concerns has been researched in various ways, which are professionally and briefly examined below. Energy-conscious improvements are well acknowledged that a critical difficulty for MDS is their short battery life, yet software developers continue to create resource-intensive apps for MDS. As a result, several technologies that can minimize battery and other resource use are required. Mobile task offloading is one of the most prevalent ways. Predicated on trade-off assessment, a novel control offloading technique has been proposed and investigated. Thanks to cloud computing's elasticity, the trade-off consideration is possible, which allows resources to be provided on request. A trade-off scrutiny of performance increase against energy savings while making offloading selections is suggested. The implementation time frame was separated into 3 interludes: permanent offload, trade-off, as well as never offload, to maximize energy savings. The architecture of a cloud offloading system is depicted in Figure 3. By building an offloading design to the cloud, a simple MoCA, mobile cloud offloading architecture, is used to address mobile devices' poor battery and computing power. In addition, an EOPMI, energy optimizing scheduler for mobile cloud computing environments, was developed to address task scheduling issues in an MCC context to minimize mobile device energy consumption too. Protection. Numerous efforts are made, nonetheless, to 3. For conclusion, address the concerns mentioned earlier. A hybrid approach (CMRAS), a cloud manager-oriented re-encryption system for portable devices, clients and fog infrastructure, addressed privacy and security concerns following the implementation or relocation of an institution's data to the cloud. 7. CMRAS has suggested a cloud-oriented re-encryption technique plus admin-oriented re-encryption to provide superior safety with the minimum sum of computing power consumption on portable gadgets. Compared to previous re-encryption methods, the anticipated cloud admin-oriented re-encryption outline displays a noteworthy enhancement in consumption of energy, response times, plus usage of resources on a mobile gadget. In the worldwide industry, mobile apps have been receiving growing acceptability. MCC has been used in several applications. Recently, various applications have been created, notably mobile medical care, portable gaming, mobile security, m-commerce, mobile communal networking, and mobile education. Meanwhile, other efforts have been made toward designing and improving MD-friendly software. Nevertheless, a cloud-oriented outline for CHIMITE, context-conscious intelligent mobile client dashboards in healthcare apps, addressed how different components may be connected and how adaptation rules and preferences can be built, upgraded, and monitored. 7. A comprehensive model is proposed, which integrates many capabilities to assist the creation of smart mobile user interfaces. It has several complexities depending on what's needed, and it also contains a context categorization scheme that separates the scheme view plus intricacy of perspective attainment from the consumer perception. Individuals can pick their settings and browse for users' choices with similar identities by saving user data and options in the cloud. It also allows users to share their preferences between apps and mobile devices and automate the updating of their priorities. Moreover, since end customer satisfaction must be attained, QoS has been a difficult challenge in program adoption and evolution. The QoE, quality of experience, of portable device clients will be improved by the rigorous standards for quality of service with the policies of SLA for fog computing vendors as well as mobile application. Nonetheless, some progress has been achieved in this course. BCMU, Cloudlet bringing the cloud to the mobile user, was developed to address excessive WAN latency while offloading computing to the cloud too. MCC is a critical technology that may be used in various service domains, like education, entertainment, finance, medical, and business. MCC boosts the portable computing performance of the device by tackling operations that are too vast and complicated for MDS to handle. The MCC enhances the MD's battery life, memory capacity, and CPU capabilities. Safety plus confidentiality, QoS, along with energy-proficient exploration on MCC are all highlighted, as well as a taxonomy based on a variety of application scenarios.